Okay, so you talk about these dinosaurs, and you accept that they're real, that they're not some figment of.
Oh yeah, definitely real. I'm writing a book on it at the moment. Actually, it's on dinosaurs.
Okay, well, look forward for that coming out.
And one of the chapters is about the dinosaurs evolve into birds. That's one of the chapters in the book.
Excellent. Well, were they on the ark? What happened to the dinosaurs?
Yes, there must have been.
Okay. So
the logic is this: if they were fossilized, God told Noah, take every kind of land animal, which means land vertebrates, animals with backbones, so no politicians, okay? But the thing is, if dinosaurs were fossilized during the flood, that means they must have been alive before the flood, which means they would have been part of the animals that Noah had to take on board. Hmm. This is the logic behind saying, yeah, dinosaurs were on the ark. But in fact, we know from looking at their growth rings on the dinosaur bones, they went through a growth spurt. You see, they would start off slowly, and then they would spurt upwards and then level off. It's called a sigmoid growth curve, okay? So it means that God bringing the animals to Noah would take them on before the growth spurt started. So after they got off the ark, they'd go through their growth spurts. The idea of having this giant brachiosaurus fully grown didn't have to be that way. It may have been only 1 ton when he went on board before his enormous growth spurt, which probably happened only in a few years. That's what they seem to measure from the growth rings, that they grew at about 5 tons per year during their growth spurt.
Wow.
But it took them a few years before they started this growth spurt. So that's a fairly recent discovery, maybe 10 years ago or so, but that seems to indicate. Oh, but also, it seems that people have seen dinosaurs. Well, I mean, for instance, Job saw a creature called behemoth, and that's Job chapter 40. Now, what is a behemoth? A behemoth is a Hebrew word. It's not an English word. They couldn't work out what it was, so they just left the Hebrew, and it's a Hebrew plural word. But if you look at the Hebrew grammar, behemah, singular, beast, behemoth, plural. But why is a singular thing being called a plural? It's called a plural of intensity. So it's a beast of beasts. And God expected Job to know what this was. And it said it had a tail like a cedar. Now, cedars were the biggest tree in the Middle East. Mm. And when you look at the imagery of comparing something to a cedar, it's always to stress the majesty of something. So when you look at what animal has a tail that would be compared to a cedar, it can't be a hippo or an elephant because they've got tiny little tails. Yeah. When you think of the dreadnought, it's discovered in Argentina in 2014 or so, and the discoverer said this is a 30-foot long, muscular, weaponized tail. Mm. So 30-foot long, weaponized, muscular tail, I think that's more what you'd think of a tail like a cedar than an elephant or a hippo. Absolutely. And various other things where humans seem to have seen things they call dragons, but seem to, when you look at them, they seem to be more like what we would now call dinosaurs. Mm. Yeah, so I think humans have seen, I think dinosaurs are gone now. Right. I mean, Rob Carter and I wrote a paper that we think dinosaurs are extinct now, but the extinction was much more recent than the 66 million years you hear about. Sure. Yeah, I'm sorry, I was just thinking about the Loch Ness Monster as a possible continuing thing, but I haven't seen evidence that convinced me that it's actually there. No, I mean, my wife and I went to Scotland for a 50th birthday holiday, and we went to Loch Ness. Of course, there are boats up and down Loch Ness all the time, and hotels on the bank of Loch Ness. I mean, if it's a plesiosaur, it's an air-breathing creature. It would have to come up for air. Right. I was thinking it had to have gills if it never came up, and what dinosaur that had a long neck also had gills, and I couldn't. Well, that's the thing. If it was a plesiosaur, it's an air-breathing creature. Yeah, yeah. Which means it must have been an air. It couldn't have had gills. Yeah. Yeah, I think it's one of those things that somebody initially got frightened by something, imagined what they saw, and then it kind of built on from there. Where every time somebody got surprised or frightened or kind of saw something, it became the monster. Well, that's why I'm a bit unconvinced by some of these reports. I want to see photographic evidence. It's almost like a camera is a dinosaur repeller. You can't ever get a picture of these things. Yeah. It's preferably a DNA sample would be nice, of course. Of course. It's funny that a living creature leaves no findable traces other than an occasional bad tourist photo. Talking about dinosaurs and their extinction,
how do the old Earth proponents who say they went extinct 66 million years ago, how do they explain the soft tissue, the finding of DNA, that sort of thing? What is their rationale behind that?
Well, at first they denied, it was denial that they found these things.
Mm-hmm.
Now it's actually denial that these things really break down. There must be some unknown method of preserving these things for millions of years.
Mm.
I mean, Dr. Schweitzer, who's been the one who's discovered it, she proposed that iron can cause a reaction to cross-link the proteins and preserve it, but is that going to get you up to 66 million years? I don't think it's going to do that. But also the reaction she proposes is called the Fenton reaction, and that's usually used to destroy organic tissue.
Mm.
The free radicals are quite damaging to organic tissue. The thing is, it would destroy certain things that Dr. Schweitzer says she's found. She says she's found certain amino acid residues, and yet we know those things are destroyed by the Fenton reaction she proposed happen to preserve it. You can't have it both ways.
Mm. So you bring in this mechanism to explain why this part exists, but then this part couldn't exist if this same reaction happened.
Exactly. And also DNA would not be explained, because DNA, we know it's a very unstable molecule. Like if you remember the 2015 Nobel Prize for Chemistry was awarded to people like Thomas Lindahl, who discovered DNA breaks down really, really quickly, and therefore living things must have mechanisms to preserve the DNA. Otherwise, we'd die. We'd be mutated mess really quickly if we didn't have these repair things to undo the chemical damage. And when you look at the data of DNA decay, you could freeze DNA to -5 Celsius. I think it's about 25 Fahrenheit. Okay, and the maximum survival time of DNA before it's broken and complete into building into this individual letters is about 6.8 million years. And yet Dr. Schweitzer's sample, which had DNA, is at least 10 times older than that, according to her dating methods. Mm. And yet the DNA is intact to give off these chemical signals. You've got DAPI coming into a groove. You've got double helix as a groove. DAPI comes into the minor groove and makes a fluorescent signal. So it means you've got intact DNA in a sample 10 times older than the maximum survival time of DNA. And yet they believe dinosaurs lived in warm climates, which means the DNA breaks down far quicker. So you've got a problem. If it's in a warm climate, it should last only a few thousand years, which is actually consistent with the data we're seeing, but not consistent with the millions of years they say. So it's very powerful evidence against dinosaurs living millions of years ago.
So I'm going to guess my next question, is that plausible? I'm going to guess your answer on that one. Maybe plausible, but not likely. How's that sound?
Well, when it comes to DNA, it's not even plausible. There's not even a plausibility of getting DNA, let alone collagen. I mean, DNA is very unstable, but even collagen, a very stable protein, to get it up to 66 million years, that's not plausible.
Okay. So
yeah, I think nothing organic.
Okay.
Well, that's why when she first found it, she said, she told the technician to do it 17 times. She just didn't believe it could be possible. So done again. This is real good. This is good science on her part. Yeah. Do this again. And then she tells Jack Horner, her boss, I mean, how could this be? You see, that it was an incredible surprise that there should be any organic material left there.
So you mentioned DNA, and we've talked about the old DNA. Modern anthropologists or even modern scientists like to say our DNA came from an ape-like ancestor. Split off, modern apes and humans split off at some point, and that we share some of the same mistakes.
Right. Oh, yes.
DNA and such. Does our DNA come from an ape-like ancestor? Do you find that?
Well, I mean, now you've heard probably that we're 99% similar to apes, but now that number's been revised to 85% or so. Mm. So the numbers come right down. But you see, if we've got 3 billion letters of DNA, 1% means 30 million differences. And the question is, how do you get 30 million differences in only 5 million years since the supposed split between humans and apes? He said, not enough time to get 30 million differences, pretty major differences. But now, if you're talking about far more than that, right? Every 1% is 30 million differences. Multiply that by 25. So if we're only 85%, no, 15, sorry, 15, because it's 85% similar, that's actually far more differences you have to get in a fairly short evolutionary time.
So
there's not enough time to get that.
So if they're correct that we descended, then the degradation's happening at a much, much greater rate than could be reasonably expected.
Well, I mean, also, see, humans have a very long generation time, so it's a matter of trying to substitute. I mean, how many mutations could be substituted, even if you have perfect natural selection, which you don't have in nature, but how many mutations could be substituted in 5 million years, given a human or 8 generation time? Nowhere near enough for even 1% difference.
Yeah. Well, I spent some time talking with Dr. Carter last week on characteristics of design, and also Dr. Behe on characteristics of design.
Oh, good stuff, yeah.
Yeah, what do you see as some of the characteristics that you can say this life shows more that it's designed than result of random variations, etc., survival pressures, that sort of thing?
Well, I mean, first of all, you've got to have a minimum complexity even for life to exist. You see, you can't invoke natural selection. I mean, natural selection does exist, but you need living things, because natural selection says this thing is fitter than this thing is going to leave more offspring. So what do you have to have before natural selection? You have to have reproduction. But to get reproduction, you have to have an enormous number of machines. And the thing is also the information, the instructions to build those machines. You see, you've got a lot of machines, but you have DNA instructions to build those machines, but you need machines to read those instructions. But the instruction reading machines are themselves coded on the DNA. So DNA needs machines it codes for to read the instructions. So which came first, the instructions or the machines? You can't have one without the other. And they must be working almost perfectly, because if you get mistakes in the instruction, in the reading, it's going to do a worse job of reading those instructions, and therefore a worse job of making the next machines, which will do a worse job of reading the instructions. So you get error catastrophe unless it's pretty much perfect from the start. And this lines up with God saying that he created everything very good. And science shows you that we could not build up from less than good to get a good reproduction machine. It had to be good from the outset. And what we're seeing now is degradation. So here's a case where science is catching up to what the Bible tells you, that everything had to be created very good, or it wouldn't even exist. It wouldn't even be living in the first place.
So within cells, we read about the ATP synthase motor, and
yes,
there are some advocates of intelligent design who say that shows clear evidence of design. Could you briefly tell us what an ATP synthase motor is?
It's one of my favorite examples, actually. Ever since it first came out around 96, I've been using that in my creation talks and my books. See, ATP is the energy currency of life. You see, your body makes its own weight in ATP every day and consumes it. And without it, you're dead. Cyanide kills you by stopping ATP production. So without ATP, you can't exist. And yet in living things, ATP is produced by this molecular motor, so tiny that 100,000 can fit side by side in a millimeter. Wow. And it goes about 10,000 revs per minute, pardon me, and it's powered by electrical current, a positive electrical current of protein, which means it has to be in a membrane to provide the voltage to drive the current, and then it goes through the bottom part like a turbine, and then it rotates the top part, which changes shape, so it actually takes the components of ATP and compresses them together and then flings it out. So the rotation is driving the reaction to create this energetic molecule. And life can't exist without, every living thing has ATP synthase.
Could that have chemically evolved in the prebiotic world?
The thing is, unless it's in the membrane, every enzyme works in reverse. This is basic chemistry here. See, so if you have ATP synthase without the special membrane, it's going to be an ATP destructor. It's going to take an ATP and use that energy to spin, you see. So it's going to destroy any ATP it came up against, even if it could arrive in the primordial soup, which it couldn't, because it's got lots of different components there. I mean, you can't get a motor without all the different components being arranged in the right place. But if it wasn't in the system, with the electrical current, it would destroy ATP that it came into contact with.
Mm.
And again, ATP is made, the instructions are on the DNA, but to read the instructions, you have to have machines using ATP. So you need ATP synthase to build ATP synthase.
Mm.
And other things, another favorite thing I've got is called topoisomerase, because think of DNA double helix, double helix thing, okay, and it's a few atoms wide, but if a DNA in each of your cells was put end to end, it would be about 6 feet long.
Right.
So think of 6 feet long, tiny little coil. Think of the old telephone landlines, which got tangled up very easily, right? See, every time DNA got read as to reproduce or to decode, it's going to get tangled up. So what it has is enzymes that will chop it, splice it, and then stick it back together again.
Wow.
These things are essential for living things, you see. But again, the instructions to build these enzymes, these topoisomerases, are encoded on the DNA, but you need to have these enzymes working to decode the instructions to build the thing.
So was it the chicken or the egg?
Well, that's the thing. Everything has to be working, everything together. I mean, antibiotics, you can tell from the way antibiotics work that you need these machines to work, because different antibiotics target different machines. You've got the fluoroquinolone antibiotics, they target those topoisomerases. So you've got this bacterium, the antibiotic means it does its job of snipping the things, but then it doesn't put it back together again.
Mm.
So the DNA becomes is shredded to smithereens, thanks to the antibiotic stopping one of the final step of this motor. Another antibiotic called oligomycin actually attacks the ATP motor.
Oh, that doesn't sound good.
Not for the bacteria, it's not. But it seems like it only attacks the bacterial one, not doesn't attack ours, thank goodness. I think it's the thing with antibiotics, to make sure it doesn't attack our things, it only attacks the bacterial things, which are a bit different. So I think the existence of antibiotics shows you the essential nature of these machines, that all of them have to be there, because just one of them going wrong and the cell dies. You guys, like us, have been bothered by the flat earth nonsense going around, but only the last few years, because about 2013 I wrote an article called The Myth of the Flat Earth. The myth is that the church taught a flat earth until Columbus. That's a total myth, because everyone in the church basically believed in a round earth. They knew it. They thought it was obvious.
Sure.
You look at Thomas Aquinas, he was 250 years before Columbus, and yet in his Summa Theologiae, he was looking for, how do you go about proving something? So let's take an example that everyone knows is obvious. He said the roundness of the earth. He thought it was so obvious, he didn't need to worry to go into detail. He still thought everyone knew that.
Yeah.
And they did, of course. So it's a myth that the church ever taught that. There's a myth of the 19th century atheists, and started with Washington Irving making all this complete false history.
Yeah.
And that's the thing. See, if the Bible taught a flat earth, why did almost no one in the church believe a flat earth?
Yeah.
So the thing is, when I wrote that article 2015, I got very good feedback from it, positive stuff. But when Dr. Carter and I wrote an article refuting the flat earth, we got a lot of negative stuff from it.
Wow.
From people who don't know what they're talking about. And the sad thing is, I think with the modern education system, I think the medieval education system, all the students going through knew astronomy and therefore knew why the earth was a globe. They could tell you why the earth is a globe long before NASA photographs or anything like that. I mean, I think modern people would have a harder job proving it than the medieval people would.
Yeah. Well, I can tell you, as a career airline pilot, I have no doubt it's a globe. I've flown through different time zones. I've seen the sun take 6 hours to set as I was flying into the west. I've gone from day to night to day in 4 hours flying toward the east. I've flown from the summer to the winter. It's just,
Wow.
in a single flight. No one who's actually left their home should doubt that the earth is round, but it's come up.
Well, I mean, I could say, like, for instance, I mean, my grandkids with me, I talked to my parents who are in New Zealand. Of course, I could tell them, well, it's night here, it's day where my parents are. You can see it's daylight there. Why do you think that is? And could just show a globe and say, well, here's the sun, here's the globe, and here's my parents, here we are, you see. So it's just a very obvious thing I could tell my grandkids. And also things like what the medievals knew is that we have different star constellations of higher up you go.
Yeah.
mean, do you see the Southern Cross when you're in Australia, for instance?
Oh yeah.
Yes, you can't see it here, can you? So
No.
yeah, again, all these things which the medieval
It's
people
much
knew.
further away from here. That's why.
Even with a powerful telescope, you can't see it. That's the thing. You get a most powerful telescope you can, you're not going to see it. You see, so the whole thing becomes. But the medieval people knew this. They knew there was different stars. The closer you got to the equator, they didn't get as far south as we can now. But they knew that the star positions change. They knew that the North Star could be navigation because the angle to the horizon was the same as your latitude. They knew that in the Middle Ages.
Yeah. Yeah.
And they knew you could, the other proof they use is, oh, get a signal fire on the beach and sail out until you can't see it. And then climb a mast and you can see it.
Yeah.
Yeah, so that's how they knew it in the Middle Age. They knew this perfectly well in the Middle Age. They knew, for instance, oh, we're in we see the eclipse on the third hour of the night and they saw it on the first hour because they're further to the east. You see, they saw it sooner. You see, these are things that the medieval people knew long before Columbus.
I mean, when they were studying logic and rhetoric and not just sharing things on YouTube?
Oh, pretty well, yeah. But as part of the medieval curriculum was logic, rhetoric.
Yeah, the trivium.
And then the quadrivium included astronomy. So any theological student had to have studied astronomy and logic first.
Yeah.
In the Middle Age, which is what it should be now. I think everyone now should study logic and astronomy before they get into theology, to formal theology.
My children are taking logic now, I can tell you.
Oh, good.
Besides Latin and Greek, so they're going to have a proper education.
I like that.
I like it. What is homochirality?
Well, okay, the issue of homochirality is that a lot of the molecules making up living things have left-handed and right-handed forms. The problem is for evolutionists that when you try to make it from a chemical soup, you get an equal number of both. But the proteins in our body have only left-handed amino acids, mirror image, but only this side, but the DNA only has right-handed sugar. And the point is you have to have homochirality, which means everything the same-handedness, all right-handed sugars in DNA and RNA, all left-handed amino acids and protein. Otherwise, the enzymes in the DNA genetic system just cannot work. But a primordial soup will only give you a 50-50 mixture.
A racemic mix.
It's called a racemic mix. And also over time, a pure homochiral mixture will degrade into a racemic mixture over time. So time is the enemy. Time leads to breakdown of things, including racemization, going to the racemic mixture. But that's a big problem. And the evolutionists haven't solved it because, in fact, they tacitly admit this because they published a paper, oh, we've finally solved the homochirality mystery, which means they hadn't solved it the previous times they said that.
Yeah. Yeah, and
so,
I've seen some of those results where they say they solved the problem. They managed to reach 5 or 10% of the right-handedness of a mix, and
that's not enough.
That's the point. It's not enough. Just because you found a way to make part of it, that's like saying I found the letters A and B in the alphabet in a forest, so now I know where the alphabet came from.
And also like, oh, I've made alphabet soup naturally, therefore I've made the works of Shakespeare naturally. That's the big difference, the letters and the sequence of the letters. Yeah, they can get alphabet soup at the most. They can't get the sequences.
Okay, for my class and for the people watching later, what do you think is the single greatest issue facing scientific apologetics today?
Oh my goodness, that's an interesting one because there are quite a few things that we come across. I think one is the issue of the age of things. I think the other is the issue, oh goodness, possibly I think we should all be aware of the claims of evolution that we all came from pond scum, which came from a primordial soup, and recognize the issue is how did the information write itself to go from primordial soup to first living cell to human beings. Well, all those would be information uphill, but what we see is going sideways or degrading. We don't see any uphill change. I think it's important to get the terms right. What are we actually addressing?
Yeah.
Accurate terminology, which means logic is a good thing too. Yeah.
Absolutely. So for the class studying scientific apologetics, I have master's and doctoral level students.
Wow.
Do you have any advice for these students?
Well, I mean, I think if you want to do science, go for it. We're actually a very pro-science organization. We have more PhD scientists at creation.com than any other Christian organization, to my knowledge. Okay, so we love science. We think science is honoring God. That's what the founders of modern science believed. They thought that Kepler said he was thinking God's thoughts after him. Newton wrote more about the Bible than he wrote about science. They saw science as honoring God by carrying out the dominion mandate. So that's what I think people need to do today. I think we should think of science as one way of glorifying God.
Well, it's been a fascinating discussion. I thank you so much, Dr. Jonathan Sarfati, for being on the show today. And
Thank you for having me.
Well, it's been exciting for me, and I hope the people who watch this on YouTube will see the links at the end and underneath the video, so they can go to creation.com and see some of your resources that you've come up with over the years. Thank you again. May God bless you.
God bless you too. Well, thanks again for having me. I appreciate that.
You're very welcome. Goodbye.
All the best to your appointment then.
Thank you.